Hello everyone, good morning.
Hello.
Hello, good morning.
Okay, let me share my screen, guys. Yeah, please confirm if my screen share is visible.
Yes, I'm able to see your screen.
Okay, thank you for the confirmation. Okay, so mm, let's go to the course content. Okay, so again, thank you everyone for joining our day one of the course. Yesterday, we have successfully discussed about the course curriculum and we had a quick demonstration of what we are going to explain. Today, let's start with chapter one discussion. So if you see the course curriculum, chapter one talks about the introduction towards API basics, client and server architecture, three-tier architecture model. So we'll start off with these 2 points now. What are APIs? How do we use them in an enterprise world? And what are the different data description formats? So I'm sure all of you are aware of what is an API. You heard of it so many times, probably in your projects. But do we understand what exactly is an API, the purpose of it, how does it work, right? So that's what I would like to talk about. And when we say an API, it stands for application programming interface. And coming to the definition of an API, what I'll do is before I write the definition of an API, I'll give a diagrammatical understanding of where exactly the APIs are being used in the real world. And then we will frame the definition so that the definition becomes more meaningful to us. So I'll take one enterprise application. Let's say this is one of the enterprise application that we are interested. Think of this application as your Amazon application, something like that. And every application has got a lot of modules in it, right? So I will say this module has got, sorry, this enterprise application has got a login module, a logout module, and make a payment module, and let's say add items to shopping cart. So let's write the names for understanding purpose. So I will say this is my login module. And this is the logout module. And this is make payments module. This is add to shopping cart module. Okay. This is your Amazon. Okay. Let's say this is your Amazon.in module. It can be a mobile app, or it can be a desktop application, or it can be a web-based application. Okay. Now, the idea of this diagram is to make you understand the definition of APIs, the purpose of APIs, where exactly APIs are playing a role in the industry. Okay, now I will ask a few simple questions and maybe you guys can help me with some answers, right? So from this particular diagram, do you think are there any modules which are dependent on each other? Which modules you think are dependent on each other? Any guess? Okay, let me answer that. So I say login and logout are dependent modules because if I have not logged in, I cannot log out. If I have not logged out, I cannot log in. Right? It's essential that you have to log in first, only then you will log out. Similarly, only if you log out, you can log in. Right? So login and logout modules are dependent here. Then login and make a payment are also dependent on each other. You know, right? I mean, in Amazon application or similarly any other e-commerce application, you cannot make a payment if you have not logged in. Right? It will definitely ask the user to log into the application if you have not logged in. Right? You can try it out on Amazon. Just go to Amazon, add an item to shopping cart without logging in, and click on make a payment. It will redirect you to the login page. So if you have to make a payment, you should be logged in. So therefore, they are dependent modules. Okay. Next module is add to shop cart and make payments. They are also dependent on each other. Right? Can I make a payment if my shop cart or if my basket is empty? No. Minimum one item has to be there in the shopping cart. Only then I can make a payment, which means add to shop cart and make a payment modules are dependent on each other. So we have taken three different combinations which are dependent on each other. Right? So now that we know what are these dependent modules, what actually happens is whenever a user clicks on logout in Amazon application or any other similar application, the logout module will send a small functional call to the login module. So it sends a request to the login module and says, this person wanted to log out. Can you check if this person is logged in? What login module does is, it will say, let me check in the database whether the person is still logged in or did he actually log in. And then the login module gives back a response to logout. And the response could be, yes, this person is logged in. So logout module says thank you, and then logout module will log you out from the server application. So here you see the logout and login are talking to each other by sending a request and response. So sending a request and response is nothing but sending data to each other, or data transfer is happening between these two modules. Similarly, if I take another example, when the user is clicking on make a payment, immediately payment will not happen. First, it will check with login module whether the guy is logged in or not. Login module will check the database and give a response. If he is logged in, payment will go to the payment gateway for next steps. If he is not logged in, it will redirect the user to login page. So here also login and make a payments are sending requests and responses, meaning data exchange is happening. Similarly, when the user is clicking on make a payment, after login request is done, then make a payment will send a request to add to shopping cart to check whether shopping cart has at least one item or not in the basket. So shopping cart market says, module says, let me check my database and give back a response. So again, this will also give a response, which means these two modules are also talking to each other by sending a request and response, meaning data exchange is happening. So when these modules are talking to each other in so many different ways, the question is, how are these modules talking to each other? Which technology is empowering them to talk to each other? Example, which technology is empowering me to talk to you and you to talk to me? In this current training, we have Microsoft Teams that's helping you and me to talk to each other. But in this diagram, you see there is a lot of traffic where a lot of requests and responses are getting exchanged between any two modules. You see the pink line, orange line, green lines. So the question is, how are these modules talking to each other? And the answer is API. So this is where the world of API comes into picture. Okay. So APIs is the mechanism the developers use or the industry is using to facilitate the data transfer from one module to another module. So this process of sending requests and receiving responses is happening through APIs. So the process of data exchange between any two modules here is happening through APIs. That's the beauty of API technology. So now if I write the definition, it becomes easy, right? So an API is an interface or a component developed to enable data transfer. When I say data transfer, I mean request and response. So to enable data transfer between any two dependent modules in an application. That's it. Now the definition is clear, right? Okay. Any questions, guys, on understanding the definition or the diagram? You can unmute and say if you have a question. If there are no questions, give me this light so that I know, okay, the point is clear. Okay, got 3 confirmations. Thank you. Okay, now we know what is an API. From the diagrammatical perspective, I have explained it clear rather than directly writing it. Now, second thing that we have to understand is, again, if you see here, so we have understood the first one. Now the second one, introduction to data description formats. So I said, okay, login and logout are sending requests and responses. They are exchanging data using API. But in which format are they sending the request and responses? Right? If I talk about the format in which I am talking to you, it's English, because between two human beings, English could be the data transfer mechanism, assuming both the parties speak English. Maybe at my home, I speak Telugu because that's the mode of communication in my home. Again, at your home, it could be some other language, right? Maybe Kannada, Tamil, Malayalam, Hindi, Gujarati, any other language, right? So that is the mode of communication between you and your friends or your office members or your colleagues or your family. When it comes to this diagram, we're talking about APIs exchanging request and response. They're exchanging data. The question is again, what is the data description format they are using? They are not human beings to talk to each other in English or any other local language, right? So they also should have some specific language that's accepted on the internet. So that answer I'm giving to you. So these modules, they talk to each other using some language, and we call that as data descriptive languages, data descriptive format or language. So there are so many data descriptive languages available for APIs to use. Just like, English is not the only mechanism for me to talk to you, right? There are thousands of languages on this globe. If you learn more languages, you have more options to communicate with someone else. Similarly, APIs also help log in, log out, and make a payment and add to shopping cart, or make a payment and log in to talk to each other in multiple data descriptive languages. Example, initially the industry used something called plain text format. So this was one of the format in the initial days used. But again, it was outdated. For security reasons, it is no longer recommended. Then the industry said APIs can communicate with each other using HTML as the mode of communication. But later it also became outdated because some security issues were there. Then XML came into picture, and I would say this is 90% outdated, which means 10% people are still using XML as the mode of communication between any two modules. Then you have JSON that replaced XML, which is 100% being used today. Apart from JSON, a few people are also using YAML. And I will say when it comes to YAML, the usage is not that high, but maybe around 30% is the usage. And then etc. So many other formats are also there. So these are the different data descriptive formats and the languages in which the developers are using to exchange data between any two modules. But most of the times you hear JSON as the data descriptive formats because that's commonly used by every organization, every developer when it comes to APIs. Okay. So now we know what are the data descriptive languages that they use. The question now is, do we understand what is plain text format, what is HTML, what is XML, what is JSON, what is YAML? right? Let me also take a little bit of time to explain this as well. Okay, so so plain text format is nothing but the normal text format that we write, right? So if I talk about this data descriptive formats, right? So first we have plain text format, also called as clear text format. Example of clear text format or plain text format is simple. Say if the login module and logout module are talking to each other, right? Maybe logout is asking login, is the person logged in? So it would say something like this. Is the user Kiran logged in? Maybe this could be the way in which the message is going, right? So it's a simple text format which has no syntax, which has no rules, which has no guidelines, like how the user has to send a message from client to server or server to client, meaning from logout module to login module or login module to logout module. Okay, so think of plain text format as something where there are no restrictions in terms of syntax. Okay, and this format is updated. Then the industry came with HTML format. HTML obviously stands for hypertext markup language. We use hypertext markup language to design the websites, to describe the websites. I'm not talking about that part of HTML that is still relevant today to design and describe the websites. I'm talking about HTML being used to transfer the data from one module to another module, and that process is outdated. Now, HTML format is simple. So you typically have this kind of thing. You will have the HTML tag, then the HTML tag will be closed. Then you will have a body tag, the body tag will be closed. Then you will have paragraph one like this. There are so much of syntaxes that the developers use, right? And then I can say, is the user Kiran logged in? Okay. So something like this is your HTML. So whenever you see this kind of formats, it is like HTML. As a tester, we don't have to write all these things, but I'm just helping you understand how it looks like. Okay. Then when HTML is deprecated or outdated, then the industry came with XML format, which is extensible markup language. Okay. And the format looks something like this. In the place of HTML, you will have XML. Guys, am I clear until this point? Any question?
Can I ask a quick question?
Yes, please go ahead.
Yeah. So if we just back up a little bit, in the browser, when you put Amazon.in, right? Um,
Mhm.
so when the page gets rendered back onto your browser, so when you're making a request for Amazon.in, so is that also an API call? And and how does the page get rendered onto your browser? Like, do you get the data and then does it get converted? Like, or do you get the page as is as a response?
Okay. So, okay, whatever you type on the browser, uh, there are two meanings to it, right? Example, if you see this one, whatever I have typed here, the question
Mhm.
is it an API? The answer is not everything we type on the browser address bar is an API. There are two things that you enter. One, you enter a URL like what you have entered here, which is not an API. Second thing is you also can enter an API here that browser can execute. Again, not all types of APIs are executable by browser. Only those APIs which are of method get can be executed by browser. So I have one API with me to show you. So this is one API. So this is not a URL. It looks like URL, but that's an API. And since it's a get method based API, I can use browser to execute it. And you see, when I press enter, I have got the response from server and it is in JSON format. You see here on the top, it says JSON. Similarly, I have one more API just to show you so that you get more clarity for the question. So this is another API whose response is also coming happily on the server in XML format, because this API works in XML format. Did I answer your question?
Yeah, so just for my clarification, so going back to the example, right? When you put in HTTP colon, / Amazon.in, so that is not an API call.
Yes.
Okay.
That's not an API call.
Okay.
Okay. Okay. So this is how your XML looks like. Okay. So in XML, you typically have the word XML. So if you see the word XML, that's a clear understanding that developer has used extensible markup language as the mode of communication. Now the question is, if you're wondering, should I know all these syntaxes? The answer is absolutely no. You don't have to know all these syntaxes. But when you see the syntax, can you take a guess whether it is in HTML format or XML format? That is important. That's why I'm saying the moment you see this kind of color coding, right? I mean, this XML, it's an XML format. If you see HTML, it's in HTML format. Okay. And finally, the industry preferred one, which is JSON, which stands for JavaScript Object Notation. Okay. Now, this is the one the industry is recommending the developers to use. Right. Now, what exactly is a JSON? It stands for JavaScript Object Notation, and it follows a key value pair structure with or without an array format. So key value pair structure means a key on the left hand side and its respective value on the right side. So I'll give an example. First, I will write the syntax of it. So it starts with a flower bracket. It ends with a flower bracket. So the moment you see flower brackets coming up, it could be JSON. And if it has key value pair inside, then 99% it is your JSON. So you have a key in double quotes, a colon to separate the key and value. If you have a second key and value, a comma is used to separate the first key value pair with second key value pair. Okay, so like this, you will have lot of keys and lot of values. For the last key and value, if you don't have anything following it, then the comma will be removed. So this is how the syntax of a key and value pair structure looks like. Now let me write an example to make it more meaningful. So again, I'll write it to a flower bracket starts, a flower bracket ends. Example, I want to say, who is the trainer for this, right? So I'll say the key is trainer and the value is Kiran. Then what course that this guy is teaching? API testing. And which tool are we using? Then I'll say tool and I'll say Postman. Then timings. So I'll say 7 a.m. to 8 a.m. IST. Like this, I can write so many keys and so many values. Whatever you want to write in key, that's your word. You can phrase it as anything, put it in double quotes, and whatever value you want to write it here and put it in double quotes. And just use comma to separate if there are more keys and values. In the last line, you should not write comma because that is the last key and value. So this is an example format of how a JSON structure looks like. This I'm making it in the simplest form without using arrays. Now, if you see, there was one API I have executed on the browser, and you see the response. So here it says the author name is yours truly. So that is a key and value. Then there is a date, which is a key, and the value is date of publication. Then you have slides, which is an array format. You see here it's an array. If I expand it, you see in index 0, I have a key called title and a value called wake up to wonder widgets. Another key called type, and its value is all. Then I have another index 1. In that I have another sub array items. Again, it has these values. So key and values look like this. If I want to change the format, I can click on raw data. Then you will see like this. So this is like an array structure, but in JSON format only. Wherever you see this square brackets coming up, the array is starting. So who writes all these syntaxes, right? The developer writes them. You don't have to write it. Developer takes care of it. But when you look at it, you should be able to say, yeah, this is JSON. And when you see something like this, you should be able to say, yes, it's XML format. So understanding the formats is important for an API test engineer. Okay. So these are the description formats that APIs uses typically while data exchange is happening between client and server. So with this, we have just completed the first point and second point in chapter 1. I'll take a pause here to see if you guys have any questions to me.
I just missed the key identification of how to differentiate like a JSON from an XML. Like, if you could just cover that again.
See, how to differentiate between JSON and XML, right? So in XML, you don't have key and value pair structure. You just have this annotations kind of thing. Like you have these tags, XML tags, body tags, message tags. And if you simply see the tags XML, it belongs to XML format. If you see the tags HTML in the example, the developer is giving you, it belongs to HTML. If you don't see XML and if you don't see HTML, definitely it could be JSON, but blindly I don't want to say it is JSON. Then you have to look out for these syntaxes, like whatever syntax I'm highlighting now. If you see this flower bracket, and then inside that in double quotes on the left side, you have a key. On the right side, you have a value in double quotes. It is a key value pair structure, meaning it's a JSON. Now, what is a key and what is a value? It's like a question and an answer. So here the question is, who is your trainer? Which is my key on the left-hand side. And the answer is Kiran, which is a value given on the right side. So on the left-hand side, you have a key. On the right-hand side, you have a value for that key. Meaning left-hand side is a question, right-hand side is an answer. So left-hand side is a puzzle, right-hand side is a solution you have. So think like that. Key and value is nothing but question and answer, puzzle and answer, riddle and answer, like that. Is it clear now?
Yes, thank you.
I have one question actually. So how do you know whether an API is being called or not? Like you said, right, while giving a logout request, there's an API call going to login. So how would we know that there is an API being called, or how would we identify an API?
Good question. Good question. I'll show you a practical answer to it. Okay. So look at the browser, and so I'll take you to a sample application. So I'm taking two different applications. It's a simple login application. It is a login screen. Here also you see a login screen, right? All I want Srijana to tell me is, when I click on login, without entering a username and without entering a password, okay, I'll just click on login. When I click on login, you have a question. Is an API call happening in the backend or not happening? Question 1. Question 2, how would I know it's happening or it's not happening? I'm going to give an answer. So if I click on login, something happened and I got an error message. Okay, forget whether I'm logged in or I got an error message. Now your question is, did we make an API call? Yes or no? Right? That's the question. And I will say, yes, we made an API call. But you are like, how do you know, Kiran, that an API call is made? So the answer is simple. When I click on login button, observe the browser and tell me, is the browser loading or not loading? That is one visual clue I'm giving to you. When I click login, I want everyone to observe, is the browser loading or not loading? I'm clicking on login, please observe. Here you can see. I'm clicking on login one more time. Just observe here in case if you are confused where to see. So did the browser load or not load when I clicked on login?
It's loading.
It's loading. So you are saying browser loaded. And you saw visually, which implies an API call is made. Okay, that's a visual clue I'm giving, not a technical answer I'm giving. Technical answer also I will give you. Similarly, if I come to the second application, when I click on login, again you tell me whether the browser is loading or not loading. If browser is loading, API call is made. If browser is not loading, API call is not made. So I'm clicking on login. Please observe this orange address bar, this tab. I'm clicking on login. Did the browser load? Okay, I'll click on login again in case if you guys have not seen it. See on the top at the tab layer. I'm clicking on login. I clicked on login.
Nothing is happening here actually.
Yeah, meaning browser did not load, which means API call is not made. That's a quick way of understanding whether API calls are going to the server or not going. Now I'll give a technical answer to support my statement. So in the first example, API calls are made. How would I know that? Simple. Right click on your browser, click on inspect. That will open the Chrome or Firefox developer tools. And go to this network tab. This is where the entire network traffic is shown to you, right? It's just like, if you sit at home, you don't know how bad the traffic is on the main road. Only if you go to the main road, you will come to know what is the traffic. Similarly, if you come to this network tab, you'll come to know what is the traffic going from your browser, which is the client, to the server. And in the traffic, you can see the API calls. So I'm on the network tab. If you already see some previous calls, click on this delete icon so that all the previous calls are removed. And now I don't care whether I'm entering username or password. I'll just click on login button. And you told me that browser is loading. And I told that API calls are made. But I'm giving a technical proof. If an API call is made, I will see it here. So I'm clicking on login. The browser loaded. And here also you see so many calls are going. There are 12 requests that went to server. You see at the bottom 12 requests. But all the 12 requests are not API calls. So when a client is talking to server, request can go to server and that request can be an API call or a non-API call. Now in this 12, not everything is an API call. Few of them are non-API calls. I'll start from the bottom. You see favicon.ico. It's an icon file. So whatever icons you have, like Facebook icon, Twitter icon, this globe icon, to load these 3 icons, this call is made. But this is not an API call. Then you have theme.js, JavaScript. So to load the content on the browser, certain JavaScripts are executed on the browser. JavaScripts are not API calls. This is also JavaScript. Next also JavaScript. Then you see CSS calls. CSS is nothing but cascade style sheets. So you see the website looks very colorful and a lot of styling is there here in terms of text boxes, this password icon, user icon. All those things are achieved using this CSS calls. And you see the above one is also CSS. CSS are cascade style sheets to beautify your website. They are not API calls. Then you see this profile.php, okay, which is this page that is loading. This can be an API call. And on the top, you see authenticate.php. And what are we doing when I click on login? I'm trying to authenticate myself to the server. So login call is nothing but authentication. And I see the first one with the same name, authenticate.php. PHP is the language used to develop this application. So the first one is the API call. And second one is loading the content on the website. So that is also an API call. So if I want to say how many API calls are there in this example, the first one and the second one are API calls. The rest of the things are non-API calls. You can call them as web calls or request calls or noisy calls. Sometimes people are like, now it is like 12 requests you are able to filter. But in my application, I see 100 requests. How can I quickly see which is an API, which is not an API? Then a shortcut is here I'm clicking on all filter. If you change it to XHR, this is where API calls will come most of the times, 90% of the times. If I click on XHR, I should see here. But now I'm not seeing it, which means is my statement incorrect? No. Sometimes if you don't see under XHR, it might come under other. And in some browsers, you see something called a document, DOC. Under document also, it will come. So since I'm not seeing an XHR, I'll try to go to other. And it's not coming even in other. Okay, maybe that DOC doc should be there. In Chrome, I see that, but in Firefox, I'm not seeing it. So if it is not working, I should not conclude that no API calls are there, because sometimes the API calls are made in different languages, right? I mean, designed in different languages. So if I'm not seeing here, then I should go back to HTML. So when I go to HTML, I'm seeing under HTML, because these are rendered on the browser, right? So I'm able to at least filter 12 to 3. Easy way to do that. And you see here document is there. So if I see document, I would have seen these two easily as a filter. So if you see document, those
Your
are the
screen is
API
not.
calls.
Yeah, I
Yeah,
don't
your
see your
screen
screen
is frozen, I think.
Yeah.
Okay, let me stop the screen share. Let me reshare again. Okay, are you seeing the screen share now on network
Yes.
tab?
Yeah.
So I'm saying here you have filters, right? HTML, CSS, XHR, etc. So XHR is one way where you can directly see API calls. If it's not coming, try document, but document tab is not there. Then you can try others. In others also, if it is not coming, you can go to HTML. In HTML, you see, I'm able to filter. In all, I had 12 requests, but in HTML, I have only 3 requests. So it is better to see here itself directly in this example to filter the calls. Okay, and you see under initiator, I have the word document. So these are the API calls that are made to server. So that's a technical proof that API calls are made to server. In the second example, I said API calls are not made, right? Technical example I'll give. Technical evidence. Go to inspect, go to network tab. Now click on login button. I'm clicking on login and I'm on all. Let me delete all the previous calls. Click on login. See, I'm clicking on login continuously, but nothing is coming here. Meaning when you don't enter username and password in this application and click on login, no API calls are going to server. But how is this error message coming required? It is coming directly from the browser, meaning from the front end application. But when I enter some username and enter some password, now if I click on login, the API call will be made to server, because this username and password is known only to the database layer whether it is correct or not. So front end will say, I cannot tell whether it is correct or not, so I'll send the request to browser database. If I click on login, here you will see the API calls. See, you see validate is there. So it's like a login call. Again, if I go to XHR, you see the get call is there. This is one. Or if I go to other, okay, I don't see. Under HTML, you see login call is there. It's a document call again. Type is document. So like this, you can figure out easily the API calls.
Okay. Yeah.
Okay, so that's how we figure out whether API calls are made to the server or not made. Any other questions, guys? Okay, let's move to the third topic, which is pretty big. I'm sure I cannot cover it completely today. It will be continuing even tomorrow. So introduction to client and server architecture. I'm sure all of you have heard of client and server, right? It is not that you have never heard of it. So what is a client and what is a server? Can anyone please help me there? Am I audible, guys? What is a client and what is a server?
Front-end application is kind of client. And server comes as a backend application.
Okay. Okay. So a client is any application or any device that submits a request. And server is any other application or a device that receives a client request to analyze it, to process it, and to give back a response to the client. Right? So let me say this is my client. And this is my server. So I said client is any application that sends a request. Right? So this client is sending a request. And server is any other application that receives client request to analyze it, to process it, and give back a response. So this server is giving back a response to the client. Now we need to talk about some examples of clients and examples of servers. So which application do we use to send a request? We use browser every day to send a request. Like I type gmail.com to check my emails. So gmail.com is a request. And I'm using Chrome browser or Firefox browser as a client. And if I'm doing automation for APIs, I use Postman as a tool. So Postman is a client. And if I'm doing front-end automation, I use Selenium as a tool, which is my Eclipse editor. So Eclipse editor is a client here. And when I'm doing performance testing, I use Jmeter as the tool. So Jmeter is my client. And if I'm doing security testing, I use Bob Suite as a tool. So Bob Suite is a client. So whatever tool you use to send a request, that's your client. So browser is an example of a client. Postman tool in our course is also an example of a client. So what is this client sending? It is sending a request. And let's call it as API request because we're talking about APIs. And by the way, we are talking about client and server architecture, because this is how the APIs can be tested if you don't understand the architecture. Now we need to talk about examples of servers. So what did I say server is? It is an application or a device that receives client request to analyze it, plus to process it, plus to give back a response to client. Examples of server applications could be your application servers, your web servers, your infrastructure servers. Examples of application servers or web servers includes Apache Tomcat, right? So Apache Tomcat is an example. Then you have Microsoft IIS, Internet Information Services. You have Nginx server. You have IBM WebSphere. Then you have Glassfish. So these are examples of your application servers or web servers on which your API source code is hosted and processed. Then I said servers also include infrastructure servers. So infrastructure servers are those servers where your entire data is hosted, right? So example, they are provided by AWS, Microsoft Azure, Google Cloud servers, and some third-party providers are also there like Controllers, etc. So servers can come in the form of software, in the form of hardware. Hardware examples I have given on the right side: AWS, Azure, Google Cloud, Controllers. Software side examples, you have the web servers or application servers where the code is deployed for ease of maintenance purpose, for ease of deployment purposes. Examples include Apache Tomcat, Microsoft IIS, IBM WebSphere, Glassfish, Nginx. I'm sure you have heard of these names at least sometimes, right? So now that's the example of server. Usually when I say what is a server, most of us, initially we say, okay, server means Google server or Amazon server or Yahoo server. Actually, they are domains. Those domains are hosted on these physical servers. Since Yahoo rented it from AWS, you can use the word Yahoo server. But the actual word you have to use is the actual provider who provided the infrastructure, right? So we have discussed now that the client sends the request and the server gives a response. Let's call it as API response. Okay, let me take a pause here. Am I clear, guys, until this diagram? Until this section? What is a client? Examples. What is a server? Examples. Do you have questions here before I extend the discussion? Okay, thank you, guys. Now, obviously, I should tell you what is an example of a request and what is an example of a response, right? So if I say, okay, so I will say, okay, Chandupriya, are you able to hear me? So that's a request I'm giving. And if Chandupriya says, yes, Kiran, I can hear you. So that's a response I got, right? So example of request and response is that. But on a client, which is my browser, so I'm typing a request, which is google.com, okay? Or let's say yahoo.com. So that's a request I'm sending on the browser. And have I got a response? Of course, yes, right? You can see a lot of content shown up on my browser for me to read what's happening in the world, right? So this is an example of a request. So I'll put it here that, hey, this is one request I have. And did I receive response? Yes, you saw the response on the browser, which is nothing but HTML response, right? This is HTML response. Any browser gives you response in HTML format. Let's change the request now. So I'm typing one more request that I'm aware of. This request I shown you a few minutes back. So this is the request I have sent on the server. And did I receive a response on the browser? Yes. In which format it is? You see JSON on the top. So this is another example where JSON response has come to us. So this is one request where I have got a JSON response. Similarly, let me change the example and hit enter. So this time, this is the request I'm sending, and this is the XML response I'm getting from server. So I'll say this is the next request I have sent and have got XML response. Like this, there are a lot of requests I can take on the browser and different responses will come. So understand the fact that when you are testing APIs using Postman tool or using browser or any other tool in the future, the responses will come, and the responses sometimes will come in HTML, sometimes in JSON, sometimes in XML, sometimes in text, sometimes in YAML, sometimes in any other format. How is the response coming in different formats? Because it is the server which is deciding the format in which the response has to be given to the client. Who is telling the server to decide the format? Your developer, because your developer is the designer and developer of the API. So developer decides for this request, I will give HTML response. For the second request, I think HTML is not correct, so I will give JSON as the response. For the third request, developer says, no, I think the third one, XML is the correct format I have to use. So developer is the deciding guy, and server is also the second deciding guy to decide in which format the response should come to the client. Am I clear here, guys? Okay, and the rest of the folks, I don't hear from you. Okay, thank you. So this is 5% of client and server architecture. What happens? Now, let's go to the second thing. Every request that we send from client, right, it has something called protocol. Now we know what is a protocol, right? Protocol is a set of rules, guidelines that helps client and server to follow certain standards and communicate with each other, right? Simple example is we are sending a request to server. Why should server give a response? Who told server to give a response? Protocol is telling it. Similarly, the client is sending a request. So who told client to send a request? I'm not telling the client to send a request, but the protocol is telling client that you should talk to server to get a response. So protocol is the guy that is helping client and server to follow certain rules, certain guidelines, certain standards to ensure seamless and peaceful communication between client and server. Okay, so I'll write the definition here. What is a protocol? It is a set of rules and guidelines that helps client and server to communicate with each other in an easy fashion. And there are so many protocols in the internet, right? So we have protocol like HTTP, HTTPS, you have FTP protocol, then secure version of FTP, then you have you have SMTP for sending emails, sending messages on the chatting applications. You have IMAP and POP3 for receiving emails, for receiving messages on the internet. Then you have LDAP protocol, which is lightweight directory access protocol used on Windows Active Directory. Then you have a SQL protocol for data transfer in relational databases. You have JDBC protocol, which is also used for data transfer in databases. Then you have MQTT protocol, which is used for big data transfers. Then you have JMS, Java Messaging Services. You have GraphQL protocol from Facebook. Like this, there are hundreds of protocols available on the internet. We don't have to learn all the protocols. In API testing, we use only these two protocols, HTTP and HTTPS. Okay, so let's talk about HTTP and HTTPS. Can anyone tell me what is the full form for HTTP protocol?
It's
Anyone?
hypertext.
HTTP?
Yeah, hypertext transfer protocol.
Okay, perfect. So I'll say hypertext transfer protocol. We see this protocol every day on your browser, right? So we know the full form. Very good. And do we also know why this protocol is created? What is the purpose of this protocol? Like, simple. What is my purpose here? To educate you guys, to share my knowledge with you. And what is your purpose? To receive that knowledge and implement in your projects, right? So the purpose of this HTTP protocol is to transfer the data between client and server. When I say data, I mean images, document, audio, video, any type of format, right? So I say it is used to transfer data such as text, images, audio, video between client and server. Then another point about HTTP protocol is it is not a secured protocol. So by design, it is not secured, which means the data that you transfer from client to server or server to client is at the risk of stealing or tampering or data modification from a third-party user or an outsider or a stranger or an attacker or a hacker. So it is an unsecured protocol by design. That is, when I say it is unsecured protocol, the data transfer happens in plain text format, which is easy for a hacker to steal your data, which could be your user credentials, which could be your credit card details, your banking details, which could be your non-sensitive data like the email content or the WhatsApp content, right? So the hackers can easily steal your data if your developer is using HTTP protocol. So to fix this problem, the industry has come up with HTTPS protocol. So HTTP is created or designed probably 1990s, when internet is just a digital newspaper. Internet was not like this in 1990s, right, or 1998. It was like a digital newspaper. You just visit a website, read the content, that's it. There is no login process. There is no email process. There is no liking, sharing, commenting. There is no online payments. There is no subscription process. There is no digital watching content. So it's like a digital newspaper, and where no login footprint is needed. So therefore, industry thought HTTP is sufficient when they designed internet. That's why it is unsecured by design. But 1 year later or 2 years later, the concept of electronic emails have come into picture. And that's when the industry said, hey, if electronic emails has to become available for every citizen, their confidential data, their personal data is there, which is like emails. Today, hardly anyone bothers about emails. But in 1999, 2000, email was a revolution, right? So to communicate with your family members who are abroad or who are in other city, instead of writing that inland letter or postcard letters, and phone was also an expensive item, so people used to write emails saying, hey, how are you doing? Our family is doing good, blah, blah, blah. So it is sensitive data that you have, right? So the concept of HTTPS has been released by the industry. So what is HTTPS? Same, hypertext transfer protocol with the security. Okay, S stands for security. And this protocol is also used to transfer the data between client and server, all the data. And the problem it fixed is, it is not an unsecured protocol by design. It is a secured protocol by design. That is, the data transfer happens in encrypted format, meaning a format which is difficult for hackers to understand. Hackers cannot decrypt it easily. Okay, so HTTPS was released to transfer the data in secured format. So how is HTTPS converting the data secured, right? So the answer is it uses cryptographic protocols such as SSL or TLS. So HTTP is not using this technology, hence it is unsecured. HTTPS is using this technology to convert the plain text into encrypted format, which means HTTP, when given the power of SSL cryptographic protocol, HTTPS has come. Similarly, HTTP, when given the power of TLS, HTTPS concept has come. In the initial days, right, probably in the year 2000 until 2005, we used SSL only. But today it is outdated. Now the industry is using only TLS certificate to transfer data in secured format. So here I have a test case for you. If your APIs are using SSL certificate, then it's a bug. If your APIs are using TLS certificate, it is your test case passing, meaning it's a success criteria. So I'll continue my discussion tomorrow on these protocols. I'm not yet done, but I know that we don't have time now. So I would like to conclude here saying under protocol, we have discussed about HTTP and HTTPS. Under HTTPS, we discussed about SSL and TLS. Okay, so we'll continue this client and server architecture discussion tomorrow as well. Any questions, guys, before we all sign off together? Okay, I see no questions. Thank you very much for your participation today. If you guys are enjoying the sessions, please complete your enrollments so that we can continue the upcoming classes as well. Okay, thank you everyone. You have a good day. Take care and stay safe. Bye-bye.
Bye. Thank you.